that 2.4. So before break, all of the lines that we graphed, the inequalities that we graphed, we were able to check 0, 0. If you can't pick 0, 0, you're going to have to pick a different point. So this one's not going to allow us to check 0, 0. So let's try to graph this inequality. Let's try to graph y is less than a minus 3x. So y is going to be strictly less than a minus 3x. So the first thing we identify, of course, is the fact that this line is going to be dotted. And that's our original. So we'll put a box around it so we don't accidentally lose it. It's already set up to graph, because when I want to graph y equals a minus 3x, well, that minus 3, that is your slope. And there's no number on the end, so it's like having a plus 0. So that means my y-intercept is 0, 0, right? If there's no number on the end, that means we can add in that 0, and that means we're going to start at 0, 0. So let's go ahead and graph this out. We're going to start at 0, 0. And then our slope is a negative 3 over 1. So that means we go down 3 and we go over 1. Down 3 over 1. That makes my new point then 1 comma negative 3. And we connect them together with a dotted line. Now, we cannot pick 0, 0. Why can we not pick 0, 0? Because it goes through that green line. So we need to pick another point that is not on the green line, and any point will work. You can pick any point that you want. Just make sure it's not on that green line. So let's pick one that we can clearly see where it's at. How about 1, 1? If we look, 1, 1 is clearly not on that line. It's way above the line. It's easy to see. So let's go ahead and check 1, 1. And we're going to check it in y is less than a minus 3x. So that's going to be filling in our pieces. 1 is less than a minus 3 times 1. And is 1 now, when we worked it out, is 1 going to be smaller than a negative 3? Is that going to be true or false? Is 1 smaller than a negative 3? No, right? It's pointing the wrong direction. So this would then be false, wouldn't it? Right? Because 1 is larger than a negative 3. So that means this half is then false. The other side is going to be true. And where do we shade? We always shade the true side. And where's the true side at? Right below, right here. That's it. When you look at your homework, you're going to see some of them that already have the line drawn for you. So I'm just going to do one of these from your homework. There's actually, I think, 3 or 4 of them in your homework like these. I'm going to work out question 2 from the homework. So on some of these, it's easier than this. On some of these, like question 3, you don't even have to graph anything. All you have to do is shade. So on question 3, they give you this equation, or this inequality. Minus 3x minus 4y is less than or equal to 12. and they give you a graph. Okay, and your graph looks like this. Okay, so that's what you're given basically in question 3. Now, all we have to do is figure out, do we shade above the line or below the line? So some of these, about a third of these questions, you're going to have the graph already there. It's given. All you need to do is figure out, do I shade above it or below it? So all we have to do is check a point. Now, can we check 0, 0? Yes, because 0, 0 is not on there. So here's 0, 0. We're going to check now 0, 0 in the original. And that comes out to be 0 on the left. And is 0 smaller than 12? Is 0 smaller than 12? Yes, it is. So that means that this side would be true. So then this is true, this is false, and where do we shade? The true half. So on several of these questions, that's all you need to do. All you need to do is go through and see if you shade above or below the line, or in the case of a vertical line, left or right. Okay, so we still see. I think almost everyone's here. Yep, just seeing who's here. Okay, so let's now go ahead and move on to 2.5. 2.4, again, there's not a lot to it, so very little in 2.4. 2.5, we're going to be talking about functions. And we're going to talk about what a function is and how a function works. So we're going to be talking about functions. Now, when we talk about functions, everything in mathematics is usually going to be a function. It's either a function or a relation, but almost everything that we use is a function. There are lots of different examples of functions. One example of a function is a gas pump. So when we go to the gas station, this is going to be the function, and I'll represent that with f of x, and you have something that goes in and something else that comes out. Now, when we go to the gas station and we pump gas, dollars go in, gallons of gas comes out. Something in, something else out. That's a function. That's the idea. And usually the x is the in part, the y is the out part. So we put something in, and we get something else out. Example of a function. So let's say we put $8 in, we get out 2 gallons of gas. Okay, that's an example of a function. Money in, gallons of gas out. Now, when you go to the gas station, there's not just one type of gas, there's different types of gas, right? So when you go to the gas station, this is another example of a function. When you go to the gas station, there's 2 or 3 different types of gasolines, and each one of them have a different price. So you might have, let's just make it easy, let's say $4 a gallon gas, you've got $4.25, right? And $4.50. So what happens with all of those? Well, those are the prices for what? 1 gallon. So this is what a function is. You take something and you get something else out. So if I go to the gas station and I pay $4, I get 1 gallon of gas. of regular, 87. If I go to the gas station and I pay $4.25, that's going to give me a gallon of premium. And then if I pay that $4.50, that's going to give you the highest level, right? So these are what you put in. This is what you get out. So different inputs can give you the same output. And that's okay. That always works. This is not a function. So this one is a function here. This one is not a function, the next one. Okay, this one doesn't make sense because this $4 is the price per gallon. Okay, and if I put $4 in, that's the price per gallon. If I put $4 in, what should I always get out? 1 gallon of gasoline, right? If I put $4 in, should I get out 8 gallons of gas? No, it doesn't make sense, right? And that's not how it works. This doesn't make sense at all. $4 in gives you a gallon of gas, not on Monday a gallon and Wednesday 8 gallons. It doesn't do that, right? It's a fixed price. One thing goes in, one thing comes out. They might all go to the same thing, but you can't split the X value. Okay, this is the end part right here. You cannot split that. So this is not a function because $4 gives only 1 gallon, never 8. If it gave you 8 gallons, you'd want to go to that gas station and get as much gas as you could, right?
Yep.
But it's not, okay? If there was a mistake at the pump, and let's say somebody didn't key the pump correctly and it gave you 8 gallons, well, everybody's going to go there because that's not correct. It should be, I put $4 in, I get out a gallon of gas. That's why it's not a function. It doesn't make sense. Now let's look at these with numbers. So I wanted to kind of give you an explanation. Sometimes I use wages. Wages are the same thing. Hours that you worked, how much money you get out in your wages. Same type of thing as the gas pump. So sometimes I use wages, sometimes I use the gasoline pump as an example. But now let's look at these in terms of numbers. The domain is what you put in, and the domain is going to be the values of X. That's your input. That's what you put in. And the range is going to be the values of Y. Sometimes it's called the target as well. Our textbook calls it the range. So when we talk about the range, sorry, that's going to be out there. That's going to be the values of Y. So the range is what you get out, and it's going to be the values of Y. Now, how do we tell if ordered pairs are a function or not? Well, ordered pairs are a function if no X values are duplicated. Because if the X values are duplicated, it would look like this here. Okay, because you have one X value going to 2 different Y values. So when we look at ordered pairs are going to be a function as long as none of the X values are duplicated. If the X values are duplicated, that means you end up with a situation like this, where you charge a fixed price, but you get out different values. And we cannot have that. So now we're going to look at some ordered pairs, and you're going to find the domain, you're going to find the range, and you're going to tell me if it's a function or not. And these are very simple. So we're going to look at these, and we're going to find the domain, the range, and then we're going to see if this is a function. Remember, domain is the values of x, range are the values of y, and ordered pairs are a function if none of the x values are duplicated. And sometimes it's helpful to make a mapping too. We don't have to make a mapping, but a lot of times I like to look at things visually, and I think a mapping helps. So this is going to be my x, and this is going to be my y over here. So when we look at these ordered pairs, 1 maps to 5, 3 maps to 7, 2 maps to 5, and 9 maps to 2. Okay, so first off, is this a function, yes or no?
Yes.
Yes, it is. Okay, how do I know it's a function? Are any of the x values duplicated at all? No, easy enough. That's not difficult. It is a function. The next one's not going to be, but this one is a function. Okay, it's a function because all the x values are different. Now let's find the domain. And normally when I list the domain out, I usually start with the smallest value of x, and I go up. And if they're duplicated, I just list them once. So let's start with the smallest value. So we have a 1, and this is your domain right here. So we've got a 1, we've got a 2, it looks like we've got a 3, and we've got a 9. So I used curly brackets, and then I just wrote them from the smallest number up to the largest. And that is your domain. Domain, again, is x. Range, we need to get that as well. Okay. Now, duplicated values are only listed one time. Yep, so we've got a 2, right? A 5 and a 7, isn't it? And that's it. 2, 5, and 7. That's your range, which is the y values. Let's do another one of these with ordered pairs, and then we'll look at a graph, which is no more difficult. Like I told you many times, 2, 3 is the most difficult section by far and away. The other sections are nothing compared to 2, 3. So let's do another one. And again, we're going to find the domain, range, and we're going to decide if this is a function or not. So here's our ordered pairs. How about 5, 8, 3, 7, 3, 9, 4, 15. Okay. Well, you don't even have to make the mapping. I like to make the mapping. I think the mapping is a visual way of looking at things. And so I always like to do the mapping, but you don't have to do the mapping. Because you can already tell that this is not a function because these two have a duplicated 3, right, on the x value. So 5 maps to 8. 3 maps to 7. 3 also maps to 9. And 4 maps to 15. And we work with functions in mathematics because we want to make sure that we always get the same answer out. Right? There's only one right answer. And this wouldn't be a function because if somebody plugs in a 3, they get a 7. But if I go plug in a 3, I get a 9. And we don't want that, right? We want one answer out. So this would not be a function. And why is it not a function? It's not a function because of the duplicated x values here. So that makes it not a function. Okay, so it's not a function because of these duplicated x values. So that makes it not a function. Let's go ahead and get our domain and our range again. Domain, values of x. Duplicated values we only write one time. So my domain would be 3, 4, and 5. And the range, we'll have to order it correctly. It looks like it's 7, 8, 9, and 15. So there's your domain, which is x, range, which is the y value. Now, when we talk about functions from a graph, what we're going to be using is what's called the vertical line test. In college algebra, you'll also learn about the horizontal one. That's with inverses, and that's one of the last parts in college algebra. But in this course, all we're going to talk about is the vertical line test. So this is going to be 4 graphs. We're going to use what's called the vertical line test. What you do is you draw vertical lines. If any line touches the graph at more than one place, it is not a function. So if it touches the graph at more than one place, it is not a function. So I'm going to give you a graph, and you're going to tell me if this graph is a function or not a function. And then we're also going to find the domain and the range. Okay, so we've got a graph here. And first off, the easy part is always, is it a function or not? Well, let's draw these vertical lines. Now, what do you notice about each line? Well, each line that I drew, each vertical line here, it only touches that blue graph at what? One point. So that means it is a function, right? If it touches it more than one place, it's not. So this is a function. Now we need to talk about the domain. Okay, now, domain. What do we know about the domain? Domain is values of x. So here's my graph, and I'm going to draw it out with my fingers here. So as I draw this graph, what's happening? It's going down, and it's also going what? Out to the left and out to the right. Okay, so it goes down, and it goes out to the left, and it goes out to the right. So it goes down and out to negative infinity, right? And down and out to positive infinity. So my domain would be negative to positive infinity. Because it goes to the left, goes to the right. What about the range? Now that's the up and down part. When I look at this, this is my up and down part, my y. When I look at this graph here, does the blue line go up at all? No. What's the highest the blue point ever is at? 5. And then what is the blue line doing? The graph is going what? Down. So my range would then be, and you've got to make sure it's in the right order, would be 5 for the largest part. We'll use a square bracket. And then where does it go to? Down to what? Negative infinity. So my range would be negative infinity to 5. You have to make sure it's in the right order, right? Because negative infinity is on the left. If it was flipped around, and let's say it was on its side, let's do another graph, and let's put this graph, similar picture, let's put it on its side. And this will be at a -2. So I want you to see the difference here. Hopefully you can see the difference between these two. Now, is this one a function? Yes or no? This graph here. This graph, is it going to be a function, do you think, or not? No. Why not? Okay, if I draw my line, what happens? If I draw a vertical line, it's going to touch that graph at what? 2 places. So if it touches it more than one place at any line, then it is not a function. What about the domain? Values of x. We're looking at values of x. X is left and right. So it's doing that. Okay? It's opening like that. When I look at my values of x, the left and right part, can it ever go back further than that -2? Can it ever go back on the left past that -2? No. Okay? Which way is it going? On left and right, it's going to the right. What's the smallest it's going to ever be? For my domain. Domain is x, so it's going to be at -2. And where does it go to? Positive infinity, right? Because it's here. It can't go back over here. It doesn't exist back there. It only goes forward. What about the range? Range is the up and down part. When we talk about the up and down part, this graph goes up to positive infinity, right? And it also does what? On the other side, it goes down to negative infinity. So what would your range then be? Negative to positive infinity, right? Because it's going up through the ceiling, also down through the floor. So that's why your range is negative to positive infinity. I want to do 2 more of these, and then we'll talk about equations and what makes an equation a function. two more graphs here. Here's one. If I give you a line like this, just a diagonal line, any diagonal line. Any diagonal line, is it going to be a function or not a function? What do you think it would be? Function or not a function? Clearly a function. So this would be a function. And what about the domain? Okay, domain is values of x. What does it do? It goes up and to the left, down and to the right. So it gets positive and it gets negative infinity. So your domain, since it goes to the left and to the right, would be negative to positive infinity. What about the range? Range is going to be the same deal. The range is going to be negative to positive infinity. What about a circle? Let's talk about a circle or an ellipse. Okay. If I give us a circle, in this case an ellipse, is this a function or not a function? Easy enough to tell. That's the easy part, right? Touches it more than one place, so this is clearly not a function. There's this line right here. We touch here and here, so it's not a function. So anytime it overlaps, not a function. What about my domain? Well, it's trapped on the x-axis. This is your x-axis again. And when I look on my x-axis, what is it trapped between? Okay, on the x-axis, this is your domain. It looks like it's trapped between what? -4 and +2, isn't it? That's where it's trapped at. What about your range? The y part. Up and down, what's it trapped between? If I look at the y part, the y is the up and down part. It looks like the range, the up and down part, is -2 to 2, isn't it? Because it's trapped here. Now we'll move on to the last part of this section. And we're going to talk about equations. And we're going to see if these equations are functions or not. And then we'll also be finding the domain. We're not going to find the range because that's more college algebra. We're going to, before break, just learn what's a function and what is not. After break, we'll learn how to find the domain. Range is going to be left for college algebra. So an equation is a function if it can be solved for y. So an equation is a function if it can be solved for y. Sometimes it's already solved for y. So that basically means these are not functions. No inequalities. Inequalities are not functions because of shading or powers on the y. Actually, even powers on the y. They don't give any odd ones, but you can't have any even powers on the y. They don't give any odd ones to worry about, but odd ones would be. But they don't even talk about that. Again, that's more of a college algebra. In this course, we just introduce functions. In college algebra, you discuss them further. So an equation is a function if it can be solved for y. So we're going to decide first if these are functions, and then after break, we're going to come back and find the domain and ranges. Or sorry, not the range, just the domain. So let's start with this one. Is this one a function? Yes or no? Yeah, I think it's a function, right? Why is it a function? Can you solve it for y? Yeah. Right. Move that x over. Divide by your 3, right? And now you solved it for y. So this one would be a function, right? Because you can solve it for y. Try another one. A lot of times, you don't have to do anything. All you have to do is look at it. Like the last one, we really didn't have to solve it all because you could tell that, yes, you could solve it for y. As long as you can solve it for y, it's a function. This one's already been solved for y, hasn't it? Right? It's y equals. So this one would also be a function. And why is it a function? It's been solved for y. Is this one going to be a function? Yes or no? It's not a function. Why is this one not a function? Right? Yeah. We can't solve it for y, right? We cannot solve it for y. Why not? Because we got that y squared. Okay? The y squared is what makes it not a function. So in this case, this one would not be a function. However, if I change it slightly, this one would be a function. Why would this one be a function? Because you can solve for y, right? You don't have to, you just have to be able to. So yes, that one's also a function. Let's do one more. Actually, we'll do two, just to make sure we understand the concepts here. This one. Function or not a function, do you think? Can we solve it for y? I think we can, can't we? Right? Because we could solve it for y by doing what? Divide by what? X. Okay? You could divide it by x, And you could get y equals 15 over x. So we solved it for y. So this one is a function. And just to make sure we don't get confused here, is this one a function or not a function? Does it matter that that x is squared at all? No. When we look if it's a function or not, what are we focusing in on? On the y part. That's all we care about. So, is this a function? Yes, it is. Why is it a function? Because we solved it for y. However, this one, what would this one be? Y squared equals x. What would this one be? Not a function, right? And why is it not a function? Because the y is squared, right? That's what we worry about, is the y squared there. So let's take a short break. We'll come back. We'll finish up this section. And I think we'll probably be able to finish up 2-6 as well. And then we'll have our exam next week. Okay, so let's go ahead and take a short break. And let's meet back here at 10:35. And we should be able to hopefully get through this section, finish it up, and the next one.